Hello, my name is Thea. I'm currently a postdoc at the Observatoire de la Côte d'Azur. And today I'm going to talk about some of the work that I did actually during my PhD, which is on the characterization of the atmosphere of WASP-76b using SPIRou, which is actually work that was done as part of the atmospheric program that was presented on Monday by Florian Debray. So I just wanted to start with a quick sort of snapshot reminder on how to characterize an exoplanet atmosphere and why. So we can observe exoplanet atmospheres using both ground-based and space-based instruments and acquire spectra of these atmospheres either in transmission or emission, and use these spectra to constrain properties concerning chemistry and the physical properties of the atmosphere. And the information that we get from concerning these properties can then be used to infer, for example, the formation, the history of the planet itself. The atmospheric signal is actually very, very small, though, being practically part of the noise, and therefore complex analysis is required to extract, to be able to constrain these atmospheric properties. And the complex analysis, such as that performed by the atmospheric pipeline that I helped develop over the course of my PhD, and that I used to acquire the results that I'll present today. So WASP-76b now is hot Jupiter, which makes it one of the best type of targets or planets to look at for characterizing the atmosphere, as it has an extended atmosphere due to its high temperature and high radiation linked to its close-in orbit. This makes it a great target for atmospheric characterization. As bigger the atmosphere, bigger the atmospheric signal. And so while it still requires a complex analysis, it is easier than looking at other targets. Another reason for looking at this exoplanet was the fact that a asymmetry was detected for its iron content, its iron composition, with there being iron detected in its evening side, but not on its morning side, leading to this sort of signal that we can see here in this figure over the course of its transit. The explanation of this lack of iron on the morning side is actually debated, with different reasons being put forward, being iron condensation and asymmetry in the temperature with the morning side being colder than the evening side, and also maybe even the presence of clouds on the morning side being behind this asymmetry as well. The idea behind using infrared data to analyze this data of this atmosphere, to look at this atmosphere, is that this could provide a different input, a different insight into this asymmetry. So I used the SPIRou transit, and the results were published last year. I don't have the time to get into the analysis of the data, so I'm just going to jump straight into the results. So I was able to, using a single transit acquired with SPIRou of this atmosphere, be able to constrain its chemical composition, some of its chemical composition, being able to constrain the abundances of water and carbon monoxide, and being able to infer upper limits for other carbon and oxygen bearing species, leading me to be able to estimate the Thea ratio for the atmosphere, which, although it wasn't precise enough to be able to infer anything as to the planet formation, I was able to find results that were consistent with other results found using near-infrared data acquired with iPrints. On the other side, another thing that I was able to infer from my results was the fact that there was a temperature symmetry for this atmosphere, with a hotter evening side than the morning side, and as well as finding hints at there being maybe clouds present on the morning side, and therefore I was able to give some input onto the properties and the asymmetry of this planet. So obviously with this 4 or 5 minute talk, I definitely didn't have enough time to really get into how I analyze data or the precision of the results. So please feel free to check out the paper where you'll be able to find much more details, and also to check out the atmospheric pipeline that I use to analyze the data. If there's one thing that I'd like you to remember from what I had to say, is that CFHT is, in my opinion, one of the best facilities to perform exoplanet atmospheric characterization, in particular with SPIRou, and this will only get better with WEN-ECHO, seeing as the extension and wavelength coverage will allow us to optimize the number of elemental ratios that we can determine that Florian mentioned on Monday are necessary to constrain the planet formation, the formation of the planets that we look at. Thank you very much.
Thank you, Thea.